Now we go to sixth problem of prac class 10b. So let x, a and b a sequence of positive numbers. Suppose this sequence is convergent, right? Prove that the series, the square root of two consecutive terms of that sequence is also convergent. So let's try to show this one, right? You know that an is convergent. An is convergent, that means sum of this infinite series is finite, right? Convergent, that. So if you rearrange these terms, let's rearrange those terms. This is your sequence here, right? So you rearrange the sequence, the series, sorry, this is the series. So here look at this, a sub 1 divided by 2 plus a sub 1 divided by 2. So this becomes a sub 1, right? What about these two terms? When you add these two terms up, you get a sub 2. So like that, you rearrange that. So this is the same. This one is the same with this. So you can write this one in this way. So you isolated a sub 1 over 2, this term, plus you write other terms in sigma notation like this, starting from 1 to infinity. Starting here, see, look at this, 1 2 3 4, n goes from 1 to infinity. If you put a sub n here, a starting from here, this term 1 2 3 4 5 6 goes to infinity. So this is go from 1 to infinity, and this is the next term of the sequence. So if you have a sub 1 here, then next term is a sub 2. So then a sub n plus a sub n plus 1, and you have to consider the average of those two terms, right? Yeah. I think this is clear for you, right? So now if you have something like this, x plus y, the average of these two numbers, then you can use the arithmetic and geometric inequality. This is bigger than or greater than or equal to square root of x times 1. So I use that one. Then you can use this property, this property to here very easily. Then you get what you get. Since this term is bigger than this one, so this series is smaller than this series, because this one is with sum of a, right? Since we know that this series is convergent, and the sum of this infinite series is finite, because this is convergent, right? So therefore here this one is finite, sum of this infinite series is finite. This series is bigger than this one. That means this is a constant value, right? Plus the infinite series of square root of n sub n times n sub n plus 1. So from here you can say that this series also convergent because of this. Using this is called comparison test, right? So let's go to second part of that problem. Find a sequence A such that this one converges and this series A sub n, this series diverges. So if this one is convergent, this implies this, but other way around, that is not true, right? If this is convergent, you cannot say this one is convergent, but you can say if this one is convergent, can say this one is convergent, this one also convergent, right? Other way is not true. So because here we have two consecutive numbers, if you consider, how do you think this problem? Right, how do you think this one? Alright, here two consecutive numbers. So if you if you consider odd numbers, odd terms and even terms of this sequence, something like this, odd terms, and even terms. So when n is odd, right. So here you have two consecutive numbers, product of two consecutive numbers. Now I consider odd terms and even terms separately, right? If you define n here and for odd terms and for even terms 1 over n, right? When you multiply these two terms, what do you get? 1. So this one times this is 1. an plus 1 all the time 1. So if you sum these up, what happens? This goes to infinity. So how do we avoid this situation? So if you want to avoid this situation, you have to add something like 2 to the how do you avoid that problem? You can say 1 over n to the power 5 or 5 or 100, anything, 100, say 1000, anything, 100. The limit of this one is infinity, this one is 0. Definitely n does not converge. So the infinity here, this does not converge. It does not converges. But the product of these two, square of n to the 99, using the p-test, sum of this, using p-test, this is convergent. But if you consider this series, it is divergent, because here you consider this subsequence. So this diverges. This diverges to infinity. So, but other term goes to 0. So this one is divergent, but this product of two consecutive, square root of product of two consecutive terms is convergent. So this one is convergent, this one is divergent. Yeah. Or you can choose this for A sub n. This one here, then n is odd number this one, even number this one, and odd number this. So when you consider the two consecutive terms, you get one product of two consecutive terms is square root of A sub n, A n plus 1 is square root of 1 over 2n. This is convergent. When you consider the sum, this series is convergent, right? But the sum of ANs, the infinite series of ANs, is divergent.